Good evening, all. Heba here. After an insightful session yesterday, we won't keep you waiting any longer. Let's dive right into today's session. Please join me in welcoming Mr. Vishnu to the virtual stage.
You aren't audible.
Hello. Yeah.
Yeah.
Okay. Okay. For today, let's start with TinkerCAD. What is TinkerCAD? And in TinkerCAD, we are having mainly three things like block coding is there. I'll just go to the website of TinkerCAD. So the website is tinkercad.com. Can just open it. So in TinkerCAD, there are three separate things like the 3D designs, circuits, and code blocks. So there are mainly three products. And TinkerCAD is completely free to be used. So yeah, I'll just share my screen. Okay. Is it visible?
Yes.
Okay. Okay. So yeah, this is the logo of TinkerCAD, and this is the website. Okay, so the website is tinkercad.com. So there are 3D designs, circuits, and code blocks. Yeah, so there are three products. Okay, and today we'll be dealing with the circuits. Okay, and if you are not having a account already, you can just sign up for an account. Okay, so maybe can you just try signing in someone? So for today's session, we'll be doing some hands-on too, like TinkerCAD in the circuit building and all. We'll be doing it live. Mm, I'll just post the link if you need. So ആരെങ്കിലും sign up ചെയ്തോ? So when you are creating the account, just personal account create ചെയ്യണം. Okay. So when you're done, please let me know. Okay. So once you're done signing up and all, please let me know. Sign up finish ആയെങ്കിൽ just tell me. Okay. Just a finished message maybe. Okay, I think in the meantime I'll just go through the circuits. Okay, maybe I'll just show you. Yeah, so we can click on. I think everyone is seeing this. Okay, so you can just click on sign up. Then you can create a personal account. So then you can sign in with Google. Okay, yeah, that's like that. Yeah, I think it's clear. Is that okay? Yeah. Okay. Okay. So I'll just maybe once you're finished, just put a message. I think it's a simple process, right? Uh, anyone have any confusions? Like maybe if you're starting a non-personal account, it will take some time. That's right. Yeah. Just try to take a personal account itself. Yeah, I think if you're signing up with email ID or something, it will be difficult. I think it will take a lot of time. Is there anyone yet to be signed up? Okay. I think everyone has signed up. Okay. Yeah. Okay. So we'll be doing five basic circuits today, and we are gonna start with the LED and battery circuit. Okay. So these are the five different circuits that we are gonna check today. Okay. Yeah. Mm, so if you want to create a new circuit, you can just click on create, then circuit, and you'll get this user interface. Okay. Yeah. ഇതിൽ എത്ര പേര് already TinkerCad use ചെയ്തിട്ടുണ്ട്? There anyone? Okay. Yeah. I think around five people. Yeah. Yeah. So this is the user interface of TinkerCAD, and this is your work area. This plain area is a work area. Then here you can see the tools and all. Sorry, the components. Okay. So these are the basic components. You can just toggle this one to maybe all, and you can see all the components over here. Okay. Then you're having different options here, like the comment adding a comment. Then I think this is visibility toggling. Then this is the wire color, wire type panel. Okay, so for now we are just gonna build a small LED circuit. So this is the LED circuit, and just for yeah, just for something. Yeah. So do you know the full form of LED? I think everyone knows it.
Light emitting diode.
Yeah. Okay, so yeah, it's the light emitting diode. Yeah, I'll just so you're having a small search bar over here, and you can search over there. So you get the LED. Can you tell me the nominal voltage of an LED?
1.5 volt.
1.5 volt. Okay. Is there any other answer? Okay. So for now we are just gonna use a 3.5 volt battery. Then we are gonna use a resistor also. Okay. Yeah. So I'll search for battery and I'll take this coin cell battery. So that's a 3.3 volt battery. Okay. And I'm having a cathode and an anode. So which is the positive one, cathode or anode? So we can just hover over this LED and we'll get the pin numbers, pin names. So it's having a cathode and an anode. So which one is positive and which one is negative? Cathode, negative or positive? Cathode. Yeah, cathode is negative. Yeah, exactly. Okay, and for the battery also we are having two terminals, positive and negative. So let's do. I'm just connecting the LED. Okay. Okay, so whenever you are connecting a positive signal or negative signal, just try to make the negative wires black and positive wires red. Okay. Yeah, that's. So I'm just gonna change the wire colors. So you can click on the wire, then you can change the color by clicking this, right? And this one will be black. So I have a small question. So is this circuit correct? Is this circuit correct or not?
Resistor is
Yeah, resistor is not there. So let's. So this is a circuit, and as you said, it's missing something. So it's missing the resistor. So here you can see the start simulation button over here, and you can just click on start simulation, and you can see the LED is glowing, right? And there is a small warning indication, so you can just hover over that, and it's written current through the LED is 61.9 milliamps, while recommended maximum is 20 milliampere. The usable lifetime of the LED may be reduced. So why is it happening? So what's the problem? So it's just as Jensen told, we need a resistor. Okay, and this is just a warning. The LED is working now. Okay, so suppose I'm okay. So I'll just delete this wire. So I have to stop the simulation. I'll just delete this wire. Also, if you want to delete something, you can just click on that, and you can click on this delete button. Okay, you can also use backspace or delete button on your keyboard also. Yeah. So for now, I'm just searching for a resistor. You can drag it and drop it here. Okay. I'll make it red. So now we have the resistor, and we are clicking on start simulation. So the LED has glown, and what's the difference from the previous one?
LED is little less bright than
Yeah, so the LEDs got fade, right? So we can just click on the resistor and we can change the value. So this is 1 kilo ohm, and so I'm just changing it to 200 ohms. and the LED got brighter, right? Suppose, so I'll just show you some funny thing. Okay, I'm just gonna delete this battery first. Okay, and I'm gonna take another battery, this one, 9-volt battery. Okay, so I'm just connecting the positive one to the anode and the negative one to cathode. So in real life scenario, what will happen if we connect it like this? Anyone know?
The bulb dies.
Yeah. So let's just try the circuit. Yeah. The LED blown up. Okay. LED is blown up. And yeah, so why is it happening? Over current ആണോ over voltage ആണോ നമ്മുടെ issue?
Voltage.
Voltage.
കറണ്ടും ഇല്ലേ? കറണ്ടും ഉണ്ടല്ലോ. Both are there, right? നമ്മൾ നേരത്തെ കണ്ട സർക്യൂട്ടിൽ there was a, I'll just stop the simulation. Okay. So in this case it's working properly. So I'll just delete this resistor and I'll connect it directly. Start simulation, and we can see there's a over current, right? So when there is an over voltage, the LED will try to drag more and more current. That's why it's getting what, blown up. Yeah. So there's an issue of both over current as well as over voltage. And let me ask you a small question. Like, നമ്മുടെ വീട്ടിൽ we have എത്ര voltage we are getting from the AC socket?
240 volt.
240 volt.
240 volts. Okay. And okay, so which one is dangerous? Higher voltage or higher current? Maybe to get someone, like maybe ഒരാളിനെ he is getting some shock. ആള് മരിക്കാനുള്ള മെയിൻ കാരണം വോൾട്ടേജ് ആയിരിക്കും കറണ്ട് ആയിരിക്കും? ഹയർ വോൾട്ടേജ് കൊടുത്താലാണോ പ്രോബ്ലം ഓർ ഹയർ കറണ്ട്?
Current.
സപ്പോസ് ഞാനൊരു എക്സാമ്പിൾ കൂടെ പറഞ്ഞുതരാം. 1000 വോൾട്ട് 1 ആംപിയർ ആണോ 1000 ആംപിയർ 1 വോൾട്ട് ആണോ ഡേഞ്ചറസ്?
So 1000 ampere one.
Okay. And okay, so like this, like yesterday, I'll just share you a small Jamboard. Yeah. Okay. Suppose this is your 220 volt source. Okay, 220 volt source, and suppose you're touching on both the terminals of the 220 volt, like the face as well as the neutral. You're just touching the face and neutral. Okay. So yeah, suppose these are two hands, maybe. Yeah. Okay, you are holding the face as well as neutral. Okay. So what will happen is that when you are holding those two wires, current will flow through your body. Yeah. Okay. Current will flow through your body. So from phase to neutral, the current will flow through your body. Okay. And suppose this is not the case. Suppose we are having another 220 volt. So there is an earth which is connected to the ground, right? So and suppose this is the ground level. Someone is standing, okay, and they are touching on the 220 volt source, okay. So suppose this is a human being, okay, and he is touching the face only. So what happens? There is neutral as well. So this body, this one is being grounded or earth, right? Okay. In that case also the face, the current will pass through the body and pass in onto the ground. Okay. So the current will get grounded through our body. Okay. And in both cases, the current passing through the body will depend upon the resistance of the human body. Okay. So according to the human body resistance, there will be an amount of current passing through the body. So in short, voltage is the most dangerous one than the current. Okay. So എത്ര voltage ഉണ്ടെങ്കിലും there is a resistance for the body. Okay. So only depending on only that, that factor will be deciding, the resistance factor will be deciding the amount of current being flown through the body. So voltage is more dangerous than current. Okay. Yeah. So here we are having a higher voltage source, and when we are giving it to the LED, will thing is that it will what will try to glow more and more and more. Okay. So this will just act like a short circuited thing, just like this. Okay. Just like it will act just like a short circuited wire, will heat up and will get blown out. So voltage is the most dangerous one and destructive one. Yeah. So is it clear? Okay. Yeah. Okay. And here we having the next circuit. So that's a potentiometer circuit. Okay. Okay. So we are having a potentiometer circuit. Mm, so I'll just take a battery. Okay. ഈ സർക്യൂട്ട് കണ്ടിട്ട് are you getting confused? This one. Confused ആവുന്നുണ്ടോ സർക്യൂട്ട് കണ്ടിട്ട്? Yes or no? I think no. Okay, I think yeah. Okay. So നേരത്തെ we have kept a resistor, right? So instead of the resistor, we are just gonna keep a potentiometer. That's it. What is a potentiometer?
Variable resistance, or we can adjust the resistance.
Exactly. So in the previous case, we have just used the constant resistance, and now we are gonna use the variable resistance. Okay, that's it. I think you are trying with me, right? Yeah, okay. So I'll just maybe yeah. Okay. Sorry. Yeah. So if you want to flip something, so suppose you have to change the swap the pins of LED. Okay. First you're having the cathode, then you're having the anode. If you want to mirror this, just click on the component and click on this button, mirror component. It can connecting the last pin to the positive, and this one I'm connecting to the negative itself. Okay, and now I'll just change the wire colors. Red. This is maybe, so this is a signal pin, right? This is a signal, right? Is this exactly a positive voltage or negative voltage? അങ്ങനെ നമുക്ക് പറയാൻ പറ്റുമോ? If this is a completely positive അല്ലെങ്കിൽ negative signal ആണെന്ന് നമുക്ക് പറയാൻ പറ്റുമോ? This one, central one. That's neither positive nor negative, right? So this is just a signal wire. So for that we'll use colors like orange, yellow, green, blue, purple, like that. For time being I'm just using orange for that. Okay, then I click on start simulation, and the LED is not glowing, right? So we can just increase the potentiometer value. Kando last എത്തിയപ്പം the LED blown out. So this is zero position, so we are slightly increasing the brightness. So if it passes some threshold it will show the warning. Yeah, there was a small warning in between, so it will show the warning and it will blow out the LED, right? Okay, so is there anyone who is seeing this for the first time, like a TinkerCad simulation and all? Is there anyone? So you do what, animation and all? First time കാണുന്ന ആരെങ്കിലും ഉണ്ടോ? Just for curiosity, yeah. Think എല്ലാരും കണ്ടിട്ടുണ്ടെന്ന് തോന്നുന്നു. Okay. Yeah, and I'll just tell you the working of potentiometer. Okay. Maybe this end explanation might be different from what you learned from college and all. Okay. Yeah. So as Denson told, this is a variable resistor, right? Suppose it's a very long resistor. Okay. And okay, so when we are hovering over the potentiometer, we can see there are three different pins. This is terminal number 1, this is terminal number 2, and this is a wiper. Okay, so let's number this one as 1, this as 2, and here we are having the wiper. Okay, in our circuit we have provided the powers like this. So 1 nil we have given negative, and in 2 we have given positive, right? Okay, so now depending on the wiper's position, the voltage will be varying. Okay, so if the wiper is moving towards the positive side, what will happen? ഈ വൈപ്പറിലുള്ള voltage, will it increase or decrease? So the wiper, I think this arrow is the wiper, right? So it's moving towards the pin number 2, or the positive pin. Okay, so it's moving towards the positive pin. So does the voltage increase or decrease? I think you can just guess the answer, maybe. So it's going towards the positive side. Suppose I'll just show you something else also. Okay, so suppose I've rotated the potentiometer and I've reached this position. Okay, so this is wiper position 1. This one was your wiper position 1, and this is your wiper position 2. Okay, so W2 ആയിരിക്കോ W1 ആയിരിക്കോ higher potential? W1 or W2? I think, yeah, I'll just tell the answer. Yeah. Okay. So W2 will be having more potential because, you know, between W2 and the pin number 2, there's still a small resistance, right? And from ground to the wiper 2 position, there's a larger resistance. So W2 voltage will be more towards the positive side. Or ഇവിടെ ഉണ്ടാവുന്ന there will be a potential drop. I think you'll get confused maybe. Okay, anyway, so there will be a small resistance over here. I think we can mention it as small r, and here we are having capital R. Okay, so since there's a very small resistance over here, we'll get most of the positive voltage. Like if it is 5 volt and if we are supplying, because of the small resistance, we'll get approximately 4.8 volt at W2. Okay, yeah. So ഇത് എന്താ നമ്മൾ W2 means wiper, when it's going towards the positive side, അവിടുത്തെ resistance കുറവായിരിക്കും, and hence voltage will be more. Okay, if we are connecting the wiper to this position, ഇവിടെ ഒരു larger resistance will be there. So wiper 3's potential will be very less, like maybe 0.5 or something. Okay, so ഈ resistor ഇങ്ങനെ ഒരു സർക്കുലർ ഫാഷനിൽ കണക്ട് ചെയ്താൽ എങ്ങനെയിരിക്കും, അതാണ് your potentiometer. Okay, so this will be your pin number 1, this is pin number 2, and here we are having the wiper. Okay, ഈ straight line resistorനെ we are just turning in a circular fashion, so we'll get the potentiometer. So ഇങ്ങനെയാണ് the potentiometer is working. മനസ്സിലായോ? Clear? Okay, ഈ കാര്യം എന്താ നേരത്തെ when you were learning about potentiometer, is this the way you have studied or learned? ഇങ്ങനെയാണോ പഠിച്ച or other way? I think maybe some other way ആയിരിക്കും. So how is this one? Is ഇത് easy ആണോ simple ആണോ this concept, like the straight line being converted into a circular fashion? Means concept understandable ആണോ എന്നാണ് ഞാൻ ചോദിച്ചത്. Okay. Okay, so I'll show you one more thing. So when you are choosing a potentiometer for your project, നിങ്ങളിപ്പം just click on the potentiometer and you can change the value. നേരത്തെ we had 250 kilo ohm over here, so അതായിരുന്നു extreme end പോയാലാണ് we are getting the brightest position, right? So I'm just going to convert this into 250 ohms. Okay, so approximately central എത്തുമ്പോഴേ we are getting a brighter LED, then we are getting the warning and slowly will blow out. Okay, ഈ extreme end പോയ blown out ആവും. So in order to prevent that, do you have any methodologies to prevent this? So ഇങ്ങനെയാണ് circuit design ചെയ്യുന്നത്. Okay, so this is a very basic circuit, and while we are building circuit build ചെയ്യുന്ന സമയത്ത് we will be facing some problems. So each and every problems we will find some solutions. So ഇപ്പോൾ നമുക്കുള്ള problem ആണ് when the potentiometer is reaching the extreme position, the LED is getting blown out. Okay, so ഇങ്ങനെ ഒരു PCB യിൽ ഒരു പ്രൊഡക്റ്റിൽ സംഭവിച്ചാൽ എങ്ങനെയിരിക്കും? So suppose we are having a small amplifier or home theater, we are just keeping on increasing the volume. So potentiometer increase ചെയ്ത് at the end ആവുമ്പോഴത്തേക്കും speaker കത്തിപ്പോയി. So is that a good thing? I think you know this, right? Can someone tell the answer? So you are designing some product, maybe Jensen, yeah. Okay, so Jensen is designing a product. Okay, maybe a sound amplifier or something, and you're giving it some customer. Okay, so the customer is using the amplifier and he is turning on the amplifier and he just increase the sound to maximum. Okay, when he increases sound to the maximum level, the speaker and the system, the entire system got blown out. So is that a good thing for your company or your product? Yes or no? Yeah, no. Okay, so we have to do something to prevent that. So what can you do? Simple answer. നമ്മൾ നേരത്തെ capacitor. Okay, any other answer? Okay, Suraj ആണോ പറഞ്ഞത്? Okay, Suraj പറഞ്ഞു we can use the capacitor. So is there any other answer? Okay, so capacitor alla, can use a resistor. So I'm just stopping the simulation. ഈ വയറിൽ resistor യൂസ് ചെയ്യുന്നതായിരിക്കും നല്ലത്. Okay, so I'm just deleting this wire. So maybe I'll add a new resistor. Okay, resistor add ചെയ്തു. Okay, so you can click on the resistor and can click on the rotate button. So resistor rotated. I'm just connecting this to the resistor. Okay, resistor connect ചെയ്തു and I'm connecting it to the potentiometer. Okay, and I'm changing the value to 220 ohms. I'm clicking on start simulation. Okay, so now I'm increasing the potentiometer value and I've increased it to the maximum level. So ഇപ്പോൾ LED blown out ആയോ? Blown out ആയോ? നേരത്തെ LED was blowing out, right? ഇപ്പോൾ LED blown out ആയില്ല. Yeah, so we can just increase the value. 220 പോരാ, we are just giving it as maybe 547. Okay, ഇപ്പം warningum പോയല്ലോ. So and I can try 400. 400 is also fine. Potentiometer maximum value ലാണ് and the LED is not getting blown out, or we aren't even getting the warning. Okay, so circuit has been designed perfectly. Okay, so this is how you do the simulation before doing a real circuit. Okay, so is that fine? Do you understand everything? Yeah. And ഇതുപോലത്തെ do you know any other software which does the same thing? Just before the hardware building, you can just try out something with the simulation. Do you know any other software other than TinkerCad? Yeah, I'll tell. So there are softwares called Proteus. Then I think CircuitVerse is there. TinkerCad is there. Yeah. So these are some of the, okay, QUCS, I don't know that. Okay, I'll just check for that. Okay, okay, so that's the new one for me. Thank you. Okay, so we are just moving on to the next circuit. Okay, so that's a light controlled LED. Okay, so now we have just used the potentiometer for controlling the brightness of the LED. Okay, now we are just going to use our LDR for controlling the brightness. Okay, so what is LDR? Photoresistor. Okay, so this is a photoresistor. I'm just going to connect the positive to the first pin, second pin, and the LED pin to the first pin. Okay, this is my positive voltage. Okay, so what is an LDR or a photoresistor? Mm, so yeah, this was my question. So what is a LDR or a photoresistor? Okay, anyway, I'll just tell the answer. Yeah. So LDR is a light dependent resistor. Okay. Yeah, exactly. Okay. So suppose this is an LDR having two pins, and you are allowing to fall some allowing some light to fall on this LDR. Okay, so this is light. Okay, so you're allowing some light to fall on the LDR. So light falls in സമയത്ത് the resistance will decrease. Okay, so when you are exposing an LDR to the light, its resistance will reduce. Okay, so this is just like another variable resistance. Okay, potentiometer pole, it's another variable resistance, but in order to vary the resistance നമുക്ക് knob ഒന്നും rotate ചെയ്യണ്ട, we can just let some light to fall on the resistor and the LDR, and the resistance will be changed. Okay, so let's start the simulation. And here we are getting a very small brightness over here. And TinkerCad, you can just click on the LDR, and ഇവിടെ കാണാം this is darkness, and this is highly intense light. Okay, so I'm just increasing the light intensity. So when I reach the maximum light, the LED has gone to the maximum level. Okay, yeah, so that's how the LDR works. I think it's clear. So TinkerCad is actually a very good platform. Like maybe initial level of tinkering and all you can do is using the TinkerCad. You have a lot of sensors and all over here. Flux sensor, then force sensor, photodiode, ambient light sensor. You have a lot of sensors over here, and you can just play with different sensors. Okay, I'll just use this gas sensor for now. Okay, circuitly use ചെയ്യുന്നില്ല, I'm just showing you. Yeah. Okay, so for simulating the gas sensor, we can click on the sensor, and നമുക്കിവിടെ കുറച്ച് gas കിട്ടി അല്ലേ? Then we can bring the gas closer to the sensor, and the resistance will vary. Okay, so I think that's clear for you. Okay, Anna? Okay, yeah. Okay, so this is our next circuit. So it's a circuit which combines a motor and a battery. Okay. searching for a motor. So I've got the motor, and yeah, I can just connect the positive wire to the positive side, negative to the negative side. ഈ color convention use ചെയ്യുന്നതിന്റെ reason do you know? ഈ positive can be connected to positive ന് നമുക്കൊരു red color, and for negative we can use a black color. So do you know the thing behind this convention? ഏത് കളർ വയർ യൂസ് ചെയ്താലും we can pass the electricity, right? പിന്നെ എന്തിനാ we are using specific colors? Yeah, to differentiate. Yeah, exactly, അത് തന്നെയാണ്, to differentiate. So ഞാൻ പോയിട്ടൊരു വീട്ടിൽ I just went to a new house. I just did all the wiring and all. Okay, എന്നിട്ട് Suraj is coming, and he's some other engineer. So he just came to the house, and he wants to do some rewiring, or maybe he wants to add a additional appliance or device to the circuit. Okay, Suraj is coming to the home. He just opened the MCB or something, and അതിനകത്ത് നോക്കുമ്പം it's full of yellow wires. ഞാൻ അതിൽ full yellow wires യൂസ് ചെയ്താ കണക്ട് ചെയ്ത. സൂരജിന് എന്തെങ്കിലും മനസ്സിലാവോ? Well, it will be complete okay ആയിരിക്കും അല്ലേ? So ഒന്നും മനസ്സിലാവത്തില്ല, full of yellow wires and all. നമുക്കൊന്നും മനസ്സിലാവത്തില്ല. Okay, so in order to differentiate the signals, or maybe to differentiate the phase, neutral, and other connections, we are using different colors. Okay, so I'll just start simulation for this one, and you can see this motor is rotating. ഇനി ഞാൻ ഈ polarity തിരിച്ചു കൊടുത്താൽ what will happen? ഇപ്പോ motor is rotating forward, ഇങ്ങോട്ട് കറങ്ങുക അല്ലേ? So we are getting a positive RPM. ഞാൻ just positive and negative തിരിച്ചു കൊടുത്താൽ എന്ത് പറ്റും? Reverse rotation. Yeah, exactly. So I'm giving negative to positive and positive to negative. Okay, I'll just start the simulation, and you can see the motor is rotating backwards with a negative RPM. Okay, and എനിക്ക് ഇതിന്റെ ഇടയ്ക്ക് ഒരു സ്വിച്ച് വെക്കണം. Okay, I'm just clicking on this one. നമ്മള് when we are connecting a switch to a circuit, നമ്മൾ എപ്പോഴും so what is the function of a switch? അതെന്താ ഒരു സർക്യൂട്ടിൽ ചെയ്യുന്നത്? Exactly what's the purpose of a switch? I'll just show you. So ഇതല്ലേ സ്വിച്ചിന്റെ സർക്യൂട്ട് ഡയഗ്രാം, or maybe the electrical representation of switch അല്ലേ? Okay, suppose I'm having a small LED over here. Here I'm having a small battery also. Okay, suppose this is a 2-volt battery. Here is your switch, and here is your LED. Okay, so what will happen when I close this switch? LED കത്തും അല്ലേ? അല്ല, yeah. So switchന്റെ function is to break the flow of current. Okay, so ഇപ്പൊ ഇങ്ങനെ open condition ആണെങ്കിൽ the circuit is not complete, right? It's broken. So when ഞാനിപ്പം I'm just erasing this, and I'm connecting the wire. Okay, ഇവിടെ കണക്ട് ചെയ്തു. അപ്പൊ എന്ത് പറ്റും? LED glow ആവും, right? So The function of a switch is to make or break a circuit. Okay. ഇവിടെ വെച്ചൊരു ബ്രേക്ക് ക്രിയേറ്റ് ചെയ്യാനോ ഓർ മേ ബി ടു ഇംപ്ലിമെന്റ് എ ഫുൾ സർക്യൂട്ട് ക്ലോസ് സർക്യൂട്ട് ഇംപ്ലിമെന്റ് ചെയ്യാനോ അല്ലെങ്കിൽ ടു ബ്രേക്ക് ഇറ്റ് ആണ് വി ആർ യൂസിങ് എ സ്വിച്ച്. ഓക്കെ. സോ ഇവിടെ കണ്ടോ ഞാൻ ഐ എം ജസ്റ്റ് ഡയറക്ട്ലി കണക്ടിങ് ദ നെഗറ്റീവ് ടെർമിനൽ ടു ദ LED and switch is always connected to the positive side of the battery. Okay, battery the positive side we are always connecting the switch, so that is also another convention. Okay, so for now I'm just gonna search for a switch. Okay, I'm taking a push button, connecting this wire to the motor. Then I'm connecting the second wire to the another terminal. I'm just converting the color. Okay, I'm starting simulation. Nothing is happening. So yeah, nothing is happening. So I'm just gonna push the button push cheyumbo the motor is rotating, right? Okay, so this is how you implement a switch in a circuit. Okay, so now let's go to the last circuit. Breadboard use ചെയ്തിട്ടുണ്ടോ എല്ലാരും? Okay, yeah, I think everyone has used it. Yeah. Okay, so now we are just gonna use a small breadboard. Okay, this is the smallest breadboard. നമുക്ക് different types of breadboard ഉണ്ട്. So this one is the breadboard mini, this is breadboard small, and this is the large breadboard. Okay, so this is the biggest one that we have in the market. Okay, so for time being we are just using this mini one. Okay, so I'm taking a motor, then I'm going to use a switch, battery, okay. So I'm connecting the negative terminal to this pole, change the color. Okay, and I'm connecting the positive terminal to the switch. Okay, ഞാൻ ഇവിടെ connect ചെയ്താൽ will be connected to the switch, right? Breadboard in the all the vertical pins are connected together. So ഞാൻ ഇവിടെ ഒരു connection കൊടുത്താൽ literally it's gonna connect to the pin of the switch itself. Push button ആ pin തന്നെ it's gonna connect. Okay, just change the color. Okay, yeah, now I'm just connecting the motor in polarity illa, you know, right? So yeah, okay, okay, but pin I'm gonna connect to this rail. This one is being connected to this one. Okay, circuit exactly just like the circuit which we have built before. Just gonna start the simulation. It's not rotating. Just clicking on the button and rotating, right? Okay, so like this we are having a lot of applications in TinkerCad. Shall we just have a 10 more minutes, or is that okay? Yeah, thank you. Okay, okay, and we are just going to the last part of our session. So it's Arduino using TinkerCad. Okay, so നമ്മൾ ഇന്നലെ we have just got introduced into the Arduino microcontroller. Okay, so today we are gonna use it in TinkerCad. Okay, you can just search for Arduino and you'll get the Arduino microcontroller. Okay, and whenever you are taking a Arduino into the workspace, നമുക്ക് can go to the coding session. So this is the coding button. You can just click on code. You can see this block coding thing over here. So നമ്മൾ block coding use ചെയ്യേണ്ട പ്രായത്തിലാണോ? Okay, no. So we'll be using text coding. Yeah, exactly. Yeah. So there's a drop down. So we'll click on that. You'll get the text coding. Okay. So this is the default code that we get whenever we are opening the coding session. Okay. So this is the code, and I'm just gonna click on start simulation. So this code will be uploaded, and there is a small LED blinking over here. And now your LED is gonna blink. Okay, so I'll just explain you the code. I think, is it visible, the code? I think now it's visible. Okay. Okay. So you're having 3 different parts in Arduino code. Okay. So you're having a void setup. You're having a void loop. So you're having 3 regions. So this is the first region. This is second region, and everything outside the void setup and void loop is the third region. So everything outside those things. Okay. So it's plain field. So like that, we are having 3 different regions for our programming. Okay. So here we are just mentioning whether the pin is going to be an output device or an input device. Here we are using a LED, right? LED output device or input device? Yesterday I have mentioned some output devices and input devices, right? Output device. Okay. So this is a pin number. Okay. LED built-in is a pin actually. So I'm mentioning LED built-in as an output device. So because LED is an output device. Okay. So I've mentioned that. Then in the void loop part, loop the function will be repeating infinite times. So whenever we are starting the microcontroller, your process will be running forever. And the void setup in the part will only be executed once. Line of code execute out. So we are just telling the Arduino to set the LED built-in pin as an output pin. Okay. So that executed one time. We are going into the void loop part. Loop in we are having something called digital write. Just like writing. So to a pin we are writing the value. LED built-in and the pin we are giving a high voltage. Then we are waiting for 1000 milliseconds. 1000 milliseconds extra seconds ആണ്?
1 second.
1 second, yeah. So we are waiting for 1 second, then we are turning off the LED, and again we are waiting for 1 second. Okay. So digital write എന്ന് പറയുമ്പോൾ നമ്മൾ മെൻഷൻ ചെയ്യുന്ന പിൻ നമ്പറിലേക്ക് we will be getting whatever signal we have written over here. High is there, low is there. High എന്ന് പറഞ്ഞാൽ 5 volt ആയിരിക്കും, low എന്ന് പറയുന്നത് 0 volt. Okay. Okay. So yeah, I'm just clicking on start simulation and the LED is blinking with an 1 second delay in between. Okay. Yeah. So suppose I'm connecting a small, I'll just zoom this out. Okay. Suppose I'm connecting a small LED. Okay. So this is your cathode. I'm just connecting it to the ground with black color. And this is your pin number 13. Okay. Okay. So yeah, I'm clicking on start simulation. Okay. There's a warning, right?
So without a resistor.
Yeah. So that's why we are seeing a small warning in between. So നമ്മൾ ഈ കോഡിനകത്ത് we have mentioned it as LED built-in, right? എന്ന് പറഞ്ഞാൽ built-in. So this is the built-in LED. So why is this external LED is also blinking? അറിയോ? I'll just show you one more thing. ഞാൻ ഈ 13th pin എന്ന് മാറ്റി I'm just keeping it on 12th pin. Okay. LED is not glowing. The external LED is not glowing and the internal LED is glowing yet. Okay. Adenda.
So 13th pin is for the internal LED. So we are taking the current or taking the.
Exactly. Yeah. So 13th means the internal LED is already connected with the 13th pin. Okay. 13th pin നിന്നായിരിക്കും LED built-in voltage എടുക്കുന്നത്. So if we are connecting some other external LED also, അതും similar ആയിട്ട് blink ആവും. Okay. Okay. So in order to make this LED blinking pin number 12, we have to change the code. LED built-in മാറ്റിയിട്ട് we'll just mention it as pin number 12. Okay. Then click on start simulation and കണ്ടോ ഇപ്പോൾ 12th പിന്നിൽ the LED is glowing, LED built-in ഇപ്പം glow ആവുന്നില്ല. Okay. So now I'm just keeping a resistor also. Okay. So if we want to vary the timing, okay. ഞാനിതിപ്പം 100 ആക്കാണ്. Stop simulation 100. Okay. Start simulation. കണ്ടോ സഡൻ ആയിട്ടൊരു ഫ്ലിക്കറിംഗ് ആണ് we are saying. Okay. So I think we have reached the end of the session. So let me ask you a small question also. So what is the frequency of the signal, the current we are getting in our household supply?
50 hertz.
50 hertz. Yeah, so that is 50 hertz. Okay. 50 hertz ആണ് നമുക്ക് കിട്ടുന്ന സപ്ലൈ. So 50 എന്ന് പറയുമ്പോൾ ടൈം എത്രയായിരിക്കും? ടൈം ഈസ് ഈക്വൽ ടു 1 upon frequency. Right? 1/50 എത്രയാ? I think it's 0. Sorry? Yeah, it's 0.02. Okay. 0.02. Okay. Okay, now any time എടുത്തിട്ട് 0.02 seconds I'm giving us the delay. 0.02 seconds എന്ന് പറയുമ്പോൾ എത്ര milliseconds ആണ്? Multiplied by 1000. എത്ര ആയിരിക്കും? എത്ര milliseconds?
20.
20. Yeah. So ഞാൻ ഈ 20 എടുത്തിട്ട് I'm giving us the delay. Start simulation. നിങ്ങൾക്ക് ബ്ലിങ്കിങ് കാണാൻ പറ്റുന്നുണ്ടോ? കാണുന്നുണ്ടോ? ലൈറ്റ് കാണാം. ബ്ലിങ്ക് ആവുന്നത് അറിയാൻ പറ്റുന്നുണ്ടോ? മേ ബി ബിക്കോസ് ഓഫ് മീറ്റിന്റെ ഫ്രെയിം റേറ്റ് കാരണം.
We can see a little bit of flickering.
Okay. So മീറ്റിന്റെ FPS is there, frame per second. So അതുകൊണ്ട് നിങ്ങൾക്ക് മേ ബി ഫ്ലിക്കറിങ് കാണാൻ പറ്റുമായിരിക്കും. പക്ഷെ എനിക്ക് റിയൽ ടൈം എനിക്ക് വളരെ മൈന്യൂട്ട് ഫ്ലിക്കറിങ് മാത്രമേ കാണാൻ പറ്റുന്നുള്ളൂ. ഓക്കെ. സോ തിങ് ഈസ് ദാറ്റ് നമ്മുടെ വീട്ടിൽ കിട്ടുന്ന സപ്ലൈ ഈസ് എ സൈൻ വേവ്, റൈറ്റ്? 220 voltsന്റെ ഒരു സൈൻ വേവ് ആണ് വി ആർ ഗെറ്റിംഗ്, റൈറ്റ്? ഇവിടെ 240, sorry. Okay, 240, and here we are having minus 240, and in between we are having 0 volt. So ഇവിടെ the brightness is increasing, then it's decreasing, വീണ്ടും decreasing അങ്ങനെ 20 milliseconds ഉള്ള ഒരു സിഗ്നൽ ആണ് നമുക്ക് വരുന്നത്, അല്ലേ? ഈ 20 millisecondsനകത്ത് ഹയസ്റ്റ് ഇത്രയും ബ്രൈറ്റ്നസ് പോവും, തിരിച്ച് വീണ്ടും ബ്രൈറ്റ്നസ് കുറയും അല്ലേ? അപ്പോൾ ഒരു ഇലക്ട്രിക് ബൾബാണ് നമ്മുടെ വീട്ടിലുള്ളതെങ്കിൽ ഇവിടെ എത്തുമ്പോഴും ഈ ഒരു റീജിയനിലും LED കത്തി നിൽക്കും, ഇവിടെയും LED ബൾബ് കത്തി നിൽക്കും. ഓക്കെ, അതെന്താ? ബിക്കോസ് ഇലക്ട്രിക് ബൾബിന് പൊളാരിറ്റി ഇല്ല. +240 ആയാലും -240 ആയാലും ഇലക്ട്രിക് ബൾബ് കത്തും. ഓക്കെ, ബട്ട് തിങ് ഈസ് ദാറ്റ് നമ്മൾ ആ ചേഞ്ച് ട്രാൻസിഷൻ വി ആർ നോട്ട് സീയിങ്, റൈറ്റ്? അതെന്താ? ആക്ച്വലി ഓൺ ആയിരിക്കുന്ന ടൈം 10+10 ആണ്. 10 milliseconds ആൻഡ് 10 milliseconds അങ്ങനെയാണ് ഓൺ ആയിരിക്കുന്നത്. പക്ഷെ ഈ ഒരു ട്രാൻസിഷനിൽ വി ആർ നോട്ട് സീയിങ് ദ വേരിയേഷൻ, ലൈക്ക് ഇത് പതുക്കെ സൈൻ വേവ് ഇൻക്രീസ് ആവുന്നു, ഡിക്രീസ് ആവുന്നു, ഇതൊന്നും നമ്മൾ കാണുന്നില്ല. എന്താ?
So too fast to catch up by a human eye.
Exactly. So that is called persistence of vision. നമുക്ക് മാക്സിമം കാണാൻ പറ്റുന്ന ഫ്രെയിം പെർ സെക്കൻഡ് എന്ന് പറയുന്നത് 24 frames per second ആണ്. സോ ദിസ് ഈസ് ലൈക്ക് 20. അപ്പോൾ 20 എന്ന് പറയുന്നത് നമുക്ക് ഹ്യൂമൻ ഐന് കാണാൻ പറ്റത്തില്ല. സോ ദാറ്റ് ഇസ് കോൾഡ് പെർസിസ്റ്റൻസ് ഓഫ് വിഷൻ, ആൻഡ് എക്സാക്ട്ലി ദാറ്റ്സ് വൈ വി ആർ നോട്ട് സീയിങ് ഫ്ലിക്കറിംഗ് ഓഫ് ബൾബ്. അപ്പോൾ നമ്മുടെ ചില സമയം നമ്മുടെ വീട്ടിലൊക്കെ ഈ LED ബൾബ്സ് ഫ്ലിക്കർ ചെയ്യാറുണ്ടല്ലേ, ഡ്യൂ ടു സം ഫോൾട്ട്. അപ്പൊ നമ്മള് മേ ബി KCB വിളിച്ചിട്ട് നമ്മൾ എന്തായിരിക്കും കംപ്ലൈന്റ് പറയുന്നത്? വോൾട്ടേജ് കുറവാന്നാ പറയുന്നത് അല്ലേ? ആക്ച്വലി അത് വോൾട്ടേജ് കുറവല്ല, ഫ്രീക്വൻസി കുറവാണ്. ഫ്രീക്വൻസി കുറയുമ്പോഴാണ് നമുക്ക് ആ ഫ്ലിക്കറിംഗ് കാണാൻ പറ്റുന്നത്. 50 Hz ഫ്രീക്വൻസി ഉണ്ടെങ്കിൽ വി വോണ്ട് സീ ദ ഫ്ലിക്കറിംഗ്. സ്റ്റിൽ ഫ്ലിക്കറിംഗ് ഈസ് ദെയർ, നമ്മുടെ ബ്രെയിൻ, ഹ്യൂമൻ ബ്രെയിനിന് പ്രോസസ് ചെയ്യാൻ പറ്റത്തില്ല. സോ ഫ്രീക്വൻസി കുറയുമ്പോഴാണ് നമ്മുടെ അപ്ലയൻസസ് ഫ്ലിക്കർ ചെയ്യുന്നത്. നമ്മളത് വിളിച്ചിട്ട് വോൾട്ടേജ് കുറവാണെന്ന് പറയും, റൈറ്റ്? ഓക്കെ, yeah, so I think we can just wind up the session. So if you have any queries or anything, you can just reach out to me. So here are my contact details if you need. Yeah. Okay, so I think we can just wind up the session, and if everything is okay, you can just put a thumbs up or anything. Yeah, thank you so much.
Thank you, Mr. Vishnu, for the incredible 2 days of learning. I hope everyone found it as enriching as we did. Don't forget to share your valuable feedback through the provided form, and for any questions, reach out to the contact number. Looking forward to see you in another session. Goodbye for now. Thank you.